Hi, Mr. Richards here. Today's lesson is on add and subtract mixed numbers, and our real-world link is on hockey. Junior and adult hockey sticks are shown below. The junior stick has a length of 3 2/3 feet. The adult stick has a length of 4 5/6 feet. We are asked to use the expression 4 5/6 minus 3 2/3 to find how much longer the adult stick is than the junior hockey stick. Now it's asking us to rename the fractions using the LCD 6. The 3 2/3, we're going to have 3. Our bottom number is going to be a 6. And if we did 3 times 2 to get to our denominator of 6, then 2 times 2 is 4. So 4 5/6 minus 3 4/6. 5/6 minus 4/6 is 1/6, and 4 minus 3 is 1. Since we're going to subtract the fractions, then the whole numbers. So our answer number 1 is 1 1/6. Explain how to find 3 7/10 minus 2 2/5. Then use your conjecture to find the difference. Well, if we look at the first one, what did we do? We rename the fractions using a least common denominator of 6 first. And then we subtracted the fractions and then the whole numbers. So in order to explain this one, I would first rename the fractions with a least common denominator of 10. Then subtract the fractions. Then subtract the whole numbers. Well, let's see if we can do that to find the difference. We would have 3 7/10 minus 2 so many tenths. Well, 5 times 2 gets us to 10, so 2 times 2 gets us to 4. And then our fractions, well, 7/10 minus 4/10 is 3/10. The bottom of the screen here. There we go. 3 minus 2 is 1. So 1 3/10. And again, I'll rewrite that just in case we can't see it there on the bottom of our screen. 1 3/10. Now here are our rules for adding or subtracting mixed numbers. To add or subtract mixed numbers, first add or subtract the fractions. If necessary, rename them using the least common denominator. Then add or subtract the whole numbers and simplify if necessary. Sometimes when you subtract mixed numbers, the fraction in the first mixed number is less than the fraction of the second mixed number. In this case, rename one or both fractions in order to subtract. And now we're going to get practice in doing all of these. Add or subtract and write in simplest form. Well, we have 6 1/8 plus 2 5/8. Well, in this case, do we have common denominators already? Yes, we do with the 8 and the 8. So if we add the fractions first, 1/8 plus 5/8 is 6/8. Now we can add the whole numbers. 6 plus 2 is 8. And I have 8 6/8, but I want to write in simplest form. So we can divide a 2 into both 6 and 8. Not to our whole number 8, though. We're not going to divide into that. We're just going to simplify our fraction here. So our answer is 8 3/4. Our next one, we have 5 1/5 plus 2 3/10. Well, we need to rename these. No, our common denominator is going to be 10. plus 2 and 3/10, so we don't need to change the 10. 5 times what is 10? Well, 5 times 2 gets me 10, so 1 times 2 gets me 2. So 2/10 is the same fraction as 1/5. Now I can add my 2/10 and my 3/10 and get 5/10. And 5 plus 2 is 7. Now you're not simplified yet. I can divide the top and bottom here by, well, 5 to get a final answer of 7 1/2. Now in C, I have ninths and I have sixths. And I don't have an easy common denominator for these. I just can't take, like in example A, where they're already common, or example B, where we just take the 5 to the 10. We actually need to change both denominators here. So if you think about your 6 and your 9 and your multiples, our multiples of 6 are 6, 12, 18, 24, and so on. And our multiples of 9 are 9 and 18. And there we already have a least common denominator of 18. I know some of you may want to take 9 times 6 to get 54, and that is a quick and easy way to get a common denominator. But as our fractions get more complicated, you'll want to find the least common denominator more times than not. That way it becomes easier to actually calculate. So we're going to rename these fractions. We have 1 and so many 18ths plus 4 and so many 18ths. How do we get from 9 to 18? Well, we multiplied that by 2, so 5 times 2 is going to get me 10. And then 6 times what was 18? Well, that was 6 times 3, so 1 times 3 is going to get me 3. And now I can add. 10 18ths plus 3 18ths is 13 18ths. And then 1 plus 4 is 5. Cannot do any simplifying there. So my final answer is 5 and 13 18ths. Now we have our little note on properties here on the side, where it says 120 1/2 plus 40 1/3 can be separated and written as 120 plus 1/2 and 40 plus 1/3, where you can regroup. For example, you could do the 1/2 plus 1/3 first, and then do the 120 plus 40, and then combine. That's possible, and that's kind of what we did here. We did the 2/10 plus 3/10 first to get the 5/10, and then did the 5 plus 2. So that's basically what we're doing here. What about subtraction here with mixed numbers? We do need to get common denominators for our example here in D. And when I look at 5 and 10, don't just multiply and get 50. Think, okay, my multiples of 5 are 5, 10. So this is going to be 5 and so many tenths minus 1 and so many tenths. And how many tenths there? Well, just 3. And then 5 times 2 is 10. So 4 times 2 is 8. If we subtract our fractions first, can I take 8 tenths minus 3 tenths? Of course. 8 minus 3 is simply 5 tenths. And 5 minus 1 is 4. Then divide by 5 to finish and simplify this. You end up with 4 1/2. What about 13 7/8 minus 9 3/4? Well, our common denominator here is going to be eighths. So we have 13 7/8 minus 9 and so many eighths. And once again, we ask ourselves, well, 4 times 2 is 8. So 3 times 2 is 6. Can I take 6/8 away from 7/8? Yes, I can. 7/8 minus 6/8 is 1/8. And then 13 minus 9 is 4. So 4 1/8. And our last problem on this page, 8 2/3 minus 2 1/2. Well, our common denominators, 2, 4, 6. for 2, 3, 6 for 3. So we are going to get these 2 sixths. And 3 times 2 was 6. 2 times 2 is 4. 2 times 3 is 6. 1 times 3 is 3. And can we take 3/6 away from 4/6? Yes. 4 minus 3 is 1/6. Actually, I forgot my 2 here. So 8 minus 2 then, with our whole number part, is 6. So I have 6 and 1/6 as my final answer. Now there is a reason why I was asking with subtraction, can I take 3/10 away from 8/10? Yeah. Can I take 6 away from 7? Yeah. Can I take 3 away from 4? Yeah. Because sometimes this second fraction is going to be a larger numerator than the first. Then you have to do something different. Subtract 7 minus 1 and 1/2. Well, as you can see now, we have several different methods for solving these questions. Method 1 involves renaming using mixed numbers. And method 2 is writing as improper fractions. Now, you can use either method. You can mix the methods as you go. If you want to use method 1 sometimes and method 2 at others, that's fine. If you want to just stick with one or the other, that's fine as well. Do whatever you need to do to be successful. Now, if we use method 1 in G, you would have 7 minus 1 and 1/2. Now, there's nothing I can take that 1/2 away from. So what we're going to rewrite this is 0 halves. I have no halves right now. I have 7 and no halves. Sorry. Now, in order to rename, I'm going to borrow 1 from the 7, take that down to a 6. Now, a whole unit is equivalent to 2 over 2 in this question. If you think about it, you take 1 away from the 6, well, that 1 is 2 halves. 2 halves is the same thing as 1. So as I rename this fraction, this becomes 6 and 2 over 2 minus 1 and 1/2. Nothing's really been changed so far. Nothing's been computed yet, at least. 7 is the same thing as 6 and 2 halves, since 2 halves is the same thing as 1, and 6 plus 1 is 7. I'm just renaming this in order to subtract, because now I can take 1 away from 2. 2 halves minus 1/2 is just 1/2, as 2 minus 1 is 1. And then our whole number portion, 6 minus 1 is 5. So I have 5 and 1/2. Now what if I want to write these as improper fractions? Well, my 7 minus 1.5, 7 is the same thing as 7 over 1. I can take any integer and write it over 1. And then minus, well, 1 times 2 is 2, plus 1 is 3 halves. Now I do need to find common denominator, and the lowest common denominator for 1 and 2 is 2. And what did we do? We did 1 times 2 to get us to 2, so 7 times 2 is going to get me 14 halves. And then 14 minus 3 is 11 halves. And if you want to get that back into a mixed number, well, guess what? It's 5.5. So no matter whether we rename with mixed numbers or write as an improper fraction, you'll get the same result. What about our next fraction? We have 5 3/8 minus 4 11/12. Now, I would not recommend multiplying 8 by 12 here to get your lowest common denominator. It's not going to be. If you think about your common denominators, and your multiples of 8 and 12, well, 12, 24. Can I get 8 to 24? Sure, 8, 16, 24. So this is going to be 5 and so many 24ths minus 4 and so many 24ths. 8 times 3 was 24, so 3 times 3 is 9. 12 times 2 was 24, so 11 times 2 is 22. Now ask yourself, can I take 22 away from 9? If I have 9 24ths, can I take 22 away from that? No, I cannot take 22 24ths away from 9 24ths. So I need to borrow. I need to rename my mixed numbers here. And once again, if I reduce the 5 by 4, or by 1 to make it a 4, I'm going to add to this 24 24ths, because once again, 24 24ths is the equivalent of a whole unit, a whole 1 that we borrowed. So as I rewrite this, I have 4 and 33 24ths minus 4 and 22 24ths. Well, as I subtract my fractions first, 33 minus 22 is 11 24ths. And 4 minus 4 is 0. So I don't even need to write it. My final answer is 11 24ths. Now, if I want to rename using improper fractions, we'll start off here 5 and 3/8 minus 4 and 11/12. 5 times 8 is 40, plus 3 is 43/8, minus 4 times 12 is 48, plus 11, 59. Once again, our lowest common denominator here is going to be 24. Now in this method, method 2, one of the dangers is you're going to have larger numbers. So 43 times 3 is going to be 129. And how did I get that 3? And why is it a 3? 8 times 3 was 24. 43 times 3 is 129. 12 times 2 is 24. So 59 times 2 is 118. And 129 minus 118 is 11 24ths. And sure enough, we get the same answer using both methods. So some of you are going to go, well, this is kind of weird. There's a lot of work here. Some of you may go, these are really big improper fractions. I don't know if I want to compute with 129 and 118 just to get this. Both have their disadvantages. Both have their advantages. Here you don't have to borrow with improper fractions. You just make them improper fractions, you find your common denominators, you subtract, and sometimes you need to rewrite as a mixed number. With the renaming mixed numbers method, you are going to have to borrow, but you are dealing with slightly smaller numerators than you are with improper fractions. So both have advantages, both have disadvantages, and you need to figure out which you're going to like to use the most. Now, if we just practice this a couple of more times, just to make sure we've got it, we have 11 2/5 minus 2 3/5. Now, don't make the classic mistake here of just saying, oh, that's 1/5, 2 minus 3, 3 minus 2, same diff, same thing. No, no, no. If I have 2/5, can I take 3 away from 2? No. So I need to rename. Now, luckily, we already have common denominators here. As I go to rename, we'll reduce the 11 by 1 to make that a 10. And then we'll just add the 5/5 to this fraction, since again, if I'm borrowing 1, 5/5 is the same thing as 1. So as I rewrite this and rename this, this is 10 7/5 minus 2 3/5. And 7 minus 3 is 4/5. And 10 minus 2 is 8, so 8 4/5. as an improper fraction, well, if I have 11 and 2/5 minus 2 and 3/5, 11 times 5 is 55, plus 2 is 57/5, minus 2 times 5 is 10, plus 3 is 13/5. I already have common denominators with the fifths, so now I just need to subtract. 57 minus 13 is 44/5. Now, though you may remember how to get a larger improper fraction back into a mixed number by dividing the numerator on the inside, denominator on the outside. 5 goes into 44 8 times, and you're left with 4. So this is 8 and 4/5. And of course, you get the same thing. And one last example like this. We have 8 minus 3 and 3/4. Now, once again, I have nothing here. There's a big fat nothing. So I have a little bit of room to be somewhat creative here and come up with my own denominator. Well, I say somewhat creative because you might as well just use the same denominator here as in your second fraction, which is the 4. So you might as well just write this as 0/4. Now, I can't take 3 away from 0 without getting into negative territory, and we don't want that here. So I'm going to borrow from the 8 and make that a 7, and add 4/4 here, and result in 7 and 4/4 minus 3 and 3/4. And once again, 7 and 4/4, as funny as it might look, 4/4 is 1. 7 with 1 is 8. It's the same number. 4/4 minus 3/4 is 1/4. 7 minus 3 is 4. So I get 4 and 1/4. Now I'm guessing we'll end up with 17/4 over here. Let's find out. If I have 8 minus 3 and 3/4, once again, any integer can be rewritten as a fraction over 1, so 8 over 1 minus, now 3 times 4 is 12, plus 3 is 15/4. Now I need to find common denominators here, and that's going to be 4. And I already have my 15/4, and well, 1 times 4 is 4, so 8 times 4 is 32. And hey, what do you know? 32 minus 15 is 17/4, which is the same thing as 4 and 1/4. So hey, we got it right. Woohoo! Let's move on. But wait, there's more. 2 more examples of this. 3 and 1/4 minus 1 and 3/4. Method 1, rename mixed numbers. Well, if we have 3 and 1/4 minus 1 and 3/4, cannot take 3 away from 1. So let's borrow. That becomes 2. Add the 4/4 back. We have 2 and 5/4 minus 1 and 3/4. And this is 1 and 2/4. I actually did that in the wrong order. Should be the 2/4 then the 1, but simplify by dividing by 2 on top and bottom, and you get 1 1/2. As improper fractions, 3 and 1/4 is 13/4 minus 7/4. 13 minus 7 is 6/4, which is the same thing as 3/2, which is the same thing as 1 1/2. Now, just because we've been borrowing a lot and renaming a lot here, just be careful that you don't do this on fractions you don't need to. Remember, the first few examples today, you didn't need to do these. Just pay attention. Go, I can't take 3 away from 1, so I need to rename, or I need to write as improper fractions. Just, be careful. Now, with our 16 minus 5 and 5/6, once again, You can be somewhat creative, but might as well just call that a 0/6 with the 16. So we can borrow, reduce that by 1, add our sixths to it, and you get 15 and 6/6 minus 5 and 5/6. 6/6 minus 5/6 is 1/6, and 15 minus 5 is 10. So 10 and 1/6. To rename these as improper fractions, well, we have 16 over 1 minus 5 times 6 is 30 plus 5 is 35/6. We need to get our 16 over 6. So 1 times 6 is 6. So 16 times 6 is 96 minus those 35/6. And 96 minus 35 is 61 over 6, which is the same thing as 10 and 1/6. So, renaming as mixed numbers, writing as an improper fraction, the choice is yours. An urban planner is designing a skateboard park. The length of the skateboard park is 120 1/2 feet. The length of the parking lot is 40 1/3 feet. What will be the length of the park and the parking lot combined? So we need to choose an operation. We're looking for the parking lot combined, so it sounds like we're adding. So let's add 120 1/2 plus 40 1/3. 1/2 and 1/3, we need to find common denominators. This is going to be 120 and so many sixths plus 40 and so many sixths. Our lowest common denominator for 2 and 3 is 6. 2 times 3 is 6, so 1 times 3 is 3. 3 times 2 is 6. 1 times 2 is 2. Add these up. 3/6 plus 2/6 is 5/6. And 120 plus 140 is 160 and 5/6 feet. That's it. Thanks for participating. Good luck.